Okay, there we go. So, agenda today, quick introduction. I don't think we have anybody new on the line, but we can do roundtable later on. Going to get a demo from Nick Jackson. So thanks for that, Nick. And he's hopefully going to be showing us the performance testing on AWS. We'll then have a look at how Fast Friday's been going and a quick recap of KubeCon, which was actually really positive for the project. Very good event. Take a look at the Trello board and some of the big items that are moving across there. If anyone doesn't have access to the Trello board, today is a good time to ask for an invitation and I can send that over to you. And then Amir was going to demo something to us, but I haven't spoken to Stefan yet. Stefan, if you're able to, maybe you could show us something of the CRD.
Yeah,
sure. We'll look at what's next for the project in terms of what did I say at KubeCon, which I think you guys will kind of understand the direction already, and then we'll go around and have any other questions. So Nick, are you ready to look at your demo?
Yep.
Yep, okay.
Let me just get the right screen open. Oh no, that's... Come on. Right. Cool. Let me make this full screen. And
just increase any, I haven't seen it yet, but normally we increase font sizes.
Yeah, I'll do that. Just a second. Oh, go away, Google. No, I'm not trying to open the insert menu. Whoops. Is that readable for everybody?
I would go in a couple more.
Is that better?
Yeah.
Okay. So what I've been having a look at is benchmarking the system and looking at it from a number of angles, but the sort of the predominant angle is trying to get real world metrics, not fake metrics, such as we could get timings which are sub-millisecond for a lot of stuff if we basically did the execution of the load test right next to where the application is running. And that would look great from a performance perspective because you'd see super fast numbers, but the real world percentages, that's not how you're going to run the system in production. So looking at real world numbers is much more interesting. So what I did was I set up a 3-node cluster on AWS using T2 mediums. There was a fast gateway deployed to each of the nodes, and there was an application load balancer, AWS application load balancer, sitting in front and round robining the requests to each of the gateway nodes. So the way that works internally is that the gateway receives a request. The gateway will then forward, well, in the case of Nomad of Kubernetes, it will then forward that request to the provider, and the provider will then make a call to the particular function. So there's, in the way that I had it set up, because when I always deploy OpenFaaS, I always deploy a gateway node and a provider node for high availability on each of the sort of worker nodes in the scheduler cluster. So the gateway is always talking to a provider container which is on its local node.
Yeah.
The function, however, could be anywhere in the cluster. So that you've got a guaranteed hop from machine to machine, and then potentially to the same machine, but also potentially not. So the first test that I ran was a basic HTTP benchmark. And this is just a very simple, in essence, hello world Go HTTP server. Again, that was running, that was a container which was running behind a reverse proxy, which then had an ALB sitting in front of it. So in terms of the number of hops, it would be exactly the same, -1 than an OpenFAS function call. So running, I ran all of this on flood.io, so I could only run a single node. Flood.io uses JMeter under the hood. So I started off with running 500 users. That was on a 3-minute ramp time and a 5-minute total duration. So for a single instance of the HTTP benchmark application, which had been allocated 500 megahertz CPU and 256 meg of RAM, that was running, including the ALB, an average response time of 3 milliseconds. So then when I ran a echo go function, which was an OpenFAS function, again, 500 users. So all of these were pretty much the same in terms of the users, single instance, very different. Yeah, so in this one it is, I did a low first and then a high. Okay. So this is using very, very low CPU, very, very low RAM. And that took 6 milliseconds. So that can be broken down into the provider and the gateway. So by the time the request hit the OpenFAS gateway, passed that on to the provider, and then did the execution, it was 3.68 milliseconds on average for that call. So the ALB was adding an overhead of around about 2 milliseconds, a little bit possibly more. The actual function execution time was 1.09 milliseconds, so a millisecond to actually, for the watchdog to spawn the process and to send the request and receive the response. So that's actually really quick. If you look at the proc execution time, so the forking time, it was barely measurable. I mean, it was like something like 0.03 milliseconds. So very, very, very low latency there. So I then started to, I sort of changed the CPU and the memory. Now, I was looking at charts in Datadog. My Datadog is only a trial account, so I don't have the metrics. But basically, I was looking at CPU and memory consumption as well as I/O on the disks for the nodes when I was running all of this stuff, and they weren't even breaking a sweat. So CPU in total for a node, which would include function execution, provider, and gateway, was barely breaching 10%. So the CPU consumption was incredibly low, and that
brilliant. So sounds good.
Yeah, increased the CPU to 500 megahertz, doubled the RAM, same test, pretty much exactly the same numbers. So what that's indicating there is that the function executing at 100 megahertz and 128 meg of RAM was in no way labored in terms of CPU or memory consumption, which is what you would expect for a very, very simple echo function. I did some tests to see if increasing the number of instances would lower the latency, and it didn't. Now, that again is not surprising, because in the first test, if the CPU and the memory wasn't labored, increasing the number of instances isn't going to make any difference, because the CPU and memory is even less labored. So there's no head bottleneck in there. But again, remember, this is a very simple hello world. I'm looking for baseline numbers. Ran a few extra tests, tried a high memory, high CPU, see if that made a difference. it didn't. Where's my afterburn test? So interestingly, the Go afterburner test made a difference of. So the total difference here is 1 millisecond, but I think what's interesting there is if you, and I probably need to double check these numbers, but if you look at the provider, so the execution time on the provider was about a millisecond down. So that indicates that the afterburn template for Go is more efficient to a millisecond, or actually a 33% improvement. So we got a millisecond extra.
The other thing, Nick, to bear in mind is that watchdog may be built, because that's the OF watchdog generation 2. That might be built with a different Golang version as well.
Yeah, that
could be inherent benefits to that.
So I rebuilt the watchdog to run these tests because I wanted to be able to get the proc exec metrics and the execution metrics from inside the watchdog. So I injected some metrics into there. I'm not certain what version of Go I built those. I'd need to double check that. I've got a sneaky suspicion I built it with Go 1.9, which was the version running on my machine. But I can. That's a good point. I'm going to make that a note. So that the numbers are looking really, really good. I mean, if you look at, I ran a couple of tests. So I ran a direct function call, which is basically just running the load test directly against the Docker container, and that returned without the ALB in 3 milliseconds. Again, remember this is network to network, so this is actually going across public internet. Well, it's going across VPC inside of AWS, but it's still one network to another network. Including the ALB, it was 4, but I suspect that's rounded down. So I would anticipate about 2 milliseconds for an ALB in terms of latency. Lambda, running a node function in Lambda actually was 63 milliseconds, which I was surprised at, and I need to check those numbers against Go. And echo Go function. Why did I rerun this? I ran it with an increased number of users, so I doubled the number of users. And again, exactly at the same time, because the system wasn't in any way labored. So I think the results are really promising. It proves that there's no real inaccuracies, no inefficiencies inside of the OpenFAS system. Could you save and could you make any improvements? Potentially, but it would actually be a huge amount of work for what would amount to saving maybe something like 2 milliseconds. And again, this is your baseline, right? So your real world functions are not going to be taking 2 milliseconds. A millisecond. They're going to be taking, in the example of something like a tweet can take 100 milliseconds by the time you've uploaded a picture and hit Twitter's server. So you're getting like a 2% saving out of that. And that's, again, probably a very low, a very quick running function comparatively. So, but
this is all done in Go, which I think we had an inkling from early on that it would be extremely fast.
Yeah.
What we need to do is now to look at the same setup with Node and with Python, both in regular running and with Afterburn, and see. That's where we really want to start comparing things. I mean, I think if somebody needs very high throughput, it looks like obvious decision to use Go. You don't even need to use Afterburn there. But I think a lot of people will want to be using Python and Node.
Yeah.
So
I mean, I think Absolutely. I think those are useful numbers to have, and I'll try and do some of those tests tomorrow morning.
Okay.
I'll just set up a Go and Python template, but this is what the main intent of this was, to look at the absolute sort of baseline performance of the system, and it's good. These are really good numbers.
I appreciate that. And the UI looks really good for flood. So what parts of this are freely available? What parts would people have to pay for?
So they give you, I don't know how many hours it is. I don't know if this is a month or whether this is just an introductory, but they give you something like 3 hours of compute. So for kind of for free. So I've got like an hour and a half of that left. My Datadog, Datadog, you get free usage with, I think, like a day's worth of retention or something like that.
Okay. So I think we might need to move on to the next segment now. Was there anything else you wanted to mention just about this exercise and you finding?
So I think literally the only thing that that sort of came out of looking at these numbers is that potentially it would be useful for the alerting metrics to look at function load as an option to trigger scale, because it very much it depends on the what you're actually executing. But there's a couple of issues already in there, but that's not a big deal. I think the key point is the baseline system looks really, really stable, and it's super, super quick.
Great. Well, thank you very much. I know Stefan's done some work in this area too, from a slightly different perspective in terms of DDoSing it or trying to break it, and that's a very different kind of test to what you're doing. I think they're both really great angles for us to be looking at the project from and seeking where to improve. So thank you very much for that.
Cool. I'm just going to quickly drop out the call and then join back in on my iPad.
Okay, sure. Okay, let's get back into this. So I want to talk about FAS Friday. So FAS Friday has been running for a few weeks now, and the idea is you tweet, just like Burton's done up the top here, a picture of your computer with the website open and something that you're doing with it. And most of the people that have responded have been in the community. A few of them have been outside. And then, as you can see in the bottom left, I've basically picked winners and sent them t-shirts and stickers, and we now have buttons. So if you want a button, get in touch with me later. And then you can see myself and Jock on the right hand side wearing our t-shirts in unison there. We're actually standing on top of a container, which is quite cool. So is everyone enjoying FAS Friday? Are there any suggestions for any changes, improvements, or similar?
So I don't know if it's a problem, but the FAS Friday hashtag is used by another company. If you put FAS Friday into Twitter, it comes up with something from Puma.
Yeah.
So I don't know if that's an issue or not, but it's just kind of an interesting thing.
I think I saw that when I went in an incognito browser, because normally I wasn't seeing anything. I think it tailors it. Yeah, maybe we should find a different hashtag. All right, thanks. Opportunity to give more feedback at the end, and plus this is Burton's setup here. Really envious of this. It's absolutely huge 27-inch monitor there. I like the stickers. So I want to talk to you a bit about KubeCon. KubeCon was held in Austin, Texas, which is now becoming a new hub and tech capital in the US. Oh, I think that's Nick. So it's basically started off, I think, as an event all about Kubernetes. This year it was called KubeCon and Cloud Native Con, and had a predominant theme of being about the Cloud Native Computing Foundation. So some of you saw that we now have OpenFaaS on that foundation in the serverless compute section. And there's actually a lot of projects growing here. It seems to be the fastest growing area right now. So it's a good place to be. So up on the top left, we have Alexis. He's the chair of the TOC of the board. And he and I, and to some extent Finian, worked on a collaboration to bring ColorizeBot from Docker Swarm over to Google Container Engine, with the help of Stefan as well. He then went on to give a 5-minute keynote in front of 4,000 or 5,000 people, all about OpenFaaS and what we built together and the way that we should build componentized systems. Now, I've tweeted the video and definitely encourage you to have a look at that. It's very exciting. And it was just a real privilege to see OpenFaaS up on the big screen there. While I was there, got a lot of good feedback. This was actually from DockerCon, but Alexis reused this slide as part of his presentation, and I think we can all be really proud of this. It says, "One of the most impressive things I saw during DockerCon was the OpenFaaS project. I was simply blown away by the simplicity of OpenFaaS." And that's from Keith Townsend, who is known as the CTO advisor. He's very big in the network and VM world. And I think it's really great feedback for somebody that saw the project for the first time. Now, he particularly honed in on one of our values, which is simplicity. And I think that's great, that the fact that the project is projecting out what we want. And so when we look at the project and the future timeline, I think this is something that we should guard and we should be protective about to the extent that we can still collaborate. So if we need to raise design changes, or we want to change the way things work, introduce new services, I think we really need to look at the contribution guide, flesh out a proposal, try and work through it together so that we make sure that we kind of hold on to this. And next year and the year after, people like Keith can come back and say this again. So this is the slide that I showed at the beginning of my talk. Again, I'm really proud to be able to show the community to a big room of people. We have some newer people on here like Nenad. I actually saw Lee Capilli up on the top left at the event, and I met up with Carol from VMware and got to see a really great demo of what they're building. Burton, who's on the call there, we met up for pizza and he showed me around downtown Austin, which was really nice. And he's doing some exciting work with his company, 118 Money. And hopefully at some point in the future, we'll get to a bit more about that. The other person I spent some time with, who I don't think could make the call, is Jock, over on the top right. And Jock is at Cisco, and he set up an opportunity for me to present about OpenFaaS to the whole of his DevNet group. And they're really excited about it. We're actually building some prototypes for network scanning, and they're looking at using it for a conference coming up early April next year. So it's great just to have another, another friend in the industry for the project. Now, Amir, I'm not sure if you're actually on here, but anyone who's new, please do send me your avatar. Now, this is a quick extract from my talk, and you can see up top left, and I haven't uploaded this video yet, we had a bit of contention about NAT streaming, and I think we come to the consensus that we didn't really know what was going on, and we didn't feel very good about it. Well, actually, I went away and spent time with Peter Miron, the general manager at NATS, and figured out what we were doing wrong. And now we have 2 configuration flags, and there's an open issue on the FAS repo, and it kind of explains the best way to use NAT streaming for asynchronous work. To sum it up, you need to set a timeout for your NATS worker, and if your task, let's say it's downloading a YouTube video, exceeds that timeout, it will actually be run again. And that's part of the built-in durability of using something like NAT streaming over a regular pub sub model. So I can send something out later to help people get to grips with it. So Stefan had his colleagues there, and they were actually live tweeting. These are the tweets from their feed from Weaveworks. And up top right, they actually did a live colorize of a black and white photo during the talk, which was really fun. And then I got to demo what we were doing in the bottom left. Now you can see here that I'm applying separate YAML files. And this is generally the way we've been setting up Kubernetes. Well, I've got a pull request in motion that allows us to just use a single folder. And this is really influenced by Stefan, is to move each service into its own file. So we don't have just Faz YAML and Nats YAML. We'll have Faznetes YAML, we'll have Gateway YAML, and just break it down into smaller pieces. At the same time, also done some work around RBAC with help from Way, and also looking at some enhancements in that area. Now, I may be able to get a picture of this later on, but on the right-hand side, we have some of the companies and users that we're working with, including Lucas, who's a great member of the contributors team, and he's been pushing through some stuff to really help us out around secrets. So look out for the release we did, 0615, which has Docker Swarm secrets, and coming up will be secrets for Kubernetes as well. Qualcomm are on this picture. They bought us something like 2,000 stickers to give away at their booth, and they ran a demo where you could walk up to this Alexa and ask it about the Qualcomm board or ask it about OpenFaz. And it was I was kind of blown away by it. It would control the TV and the audio, and this website would basically change depending on what you said to it. So it's great to have, as I say, another friend, another company promoting OpenFaz and getting behind it. Citrix is added on here. I had a call with Jason from Citrix. He's actually been doing something kind of behind the scenes for the last 10 months, actually before OpenFaz was called OpenFaz and it was still called Faz. He's constructed a whole system for building functions and running them within his automation team. And he has a whole .NET MySQL database, whole package, and dashboard UI for that. I don't think it will become open source, but it is very exciting to see what they're doing with it. And I hope he'll maybe be able to demo that to us in one of the following meetings. So if you're kind of wondering, well, what should I be working on? What's important to the project? What do we need to be moving forward? I put together a Trello board and started to invite anyone who wants to be on it to be there. And the reason this is here is to look at more of a high-level roadmap of the things that are important for the project and then going to align well with it. You can see there's already some work assigned to people on there, and if you need a link, please just ask me and I'll set you up. I would say if you look at this, look at it from the right to the left, because that's probably where we can help first. So if something's released, we can test it out and promote it. If something's in testing, we can get on board and take it to the limits, a bit like what Nick's doing. And then if it's in review pending progress, that's your opportunity to input on the design. So if we start to look at how we can provide other metrics like StatsD, that will probably end up in that column. And we have in progress, so work that's already underway. So CPU limits are being put together by Nick. They could probably move into the next column. And then on the right-hand side are just ideas and things that are either not in progress or they will be at some point. So we've got opportunity for a demo now. I know that we can't look at the code for the store via the CLI, but we could look at Stefan's CRD. Stefan, are you ready?
Yep.
Okay, let's go for it.
Can you see my screen?
Yeah.
Yes. Okay, so I've been working on Kubernetes CRD and controller for OpenFaaS. The main difference between this approach and the current OpenFaaS net is that the CRD and the controller are reacting to changes inside the Kubernetes cluster. So instead of calling the controller from the gateway, you can create functions with kubectl, like you can create a deployment, a pod, whatever, and this controller will react to that event and will create deployment services, pods, scaling. I plan to add here auto-scaling as well based on Kubernetes autoscaler, pod autoscaler. And also this will allow us to do, for example, cron jobs very easily, and a lot of stuff that Kubernetes already has. So we can, using this approach, we can actually use everything inside Kubernetes that you can define in a deployment YAML. You could also define all this stuff in our function YAML. And I want to show you how a function YAML looks like. So this is the CRD. This is how you define a function. This is how you this is the definition of the custom resource of a function. So we have.
Can I just quickly offer a very brief overview? Do you have any images for this, or like an architectural diagram?
No.
No. Do you have Slack open? I've just sent one into the contributors channel. Because I know that Kubernetes is still something people are learning, and maybe this picture will just help really quick. So the idea is, with a custom resource definition, this is jargon from Kubernetes, is that, and I don't know if this picture is actually going to help you much, but basically a call would come into the API gateway, which you can see in my rough handwriting there, would normally go to faznetes, and immediately it will create a deployment and a service synchronously by calling the API. Right? That's kind of the model we use for everything else. So that should be quite familiar. What we're looking at doing is just taking the call and updating some state. And the state is called a custom resource. The custom resource is called a function. And then that will be held by Kubernetes. And so all that will happen with the call is, rather than actually us talking to Kubernetes and creating that stuff, you see as you look lower down, we'd really just create these new definitions that are kind of like deployments and services. They have a similar shape to our function, and they will sit in the cluster. And then what happens is a operator or a controller sits there saying, well, what did we want and what have we got? And then it is the one that will create the deployments and services. And it is a very new technology, right? What is the version that it becomes compatible with?
So the stable version is 1.8, but it's still beta. In 1.9 that got released the other day, it was promoted to beta 2, and yeah, anyway, beta 1 it's pretty stable. So
okay.
In 1.9 the deployment got released. So, but everybody was using deployment since beta 1. So
any quick questions before we go back into the demo? Okay, thanks for letting me interrupt.
Okay, so this is how we define our custom resource. It's his kind is function, and I was using the new URL for our new website, so it's short and looks nice. And this is how you will deploy a function. It is pretty straightforward. So all this stuff, it's telling Kubernetes we are deploying not a pod, but a function, not a service. We are having our own item that we want to deploy. And from the specs here is just the same stuff you usually have in the stack file. So in here, we'll have with secrets, whatever is missing. What you are seeing here are already implemented: labels, environments, handler image, and replicas. So I want to do a quick demo. I will compile and start the controller. And what I'm doing here is basically I am telling the controller to use my kubectl config that's sitting on my computer, but it's connects the controller to a GKE cluster that I'm using for testing. And in order to deploy a function, you'll just use kubectl apply. Do you see this? Or should I increase?
I'm seeing it. It's a good size.
Deploying a function is just kubectl apply the YAML file. In here, you can see that the controller has started. 1 second. So it's that I'm using two Go routines. One Go routine watches for changes, and one Go routine will apply the changes. This is, you can configure all that. I will apply the function. And here the controller reacts immediately because Kubernetes will tell the controller, we have a new function item, do your stuff with it. And all these logs, what they are doing, if we do kubectl get all, it created a deployment, a replica set, 2 pods, and a service. So like now the gateway does by calling the fastnatives API, and the fastnatives API will create all this stuff. In here, you push a function definition to Kubernetes, and the new controller will just create all this stuff. You can also change something inside the YAML, like replicas, labels, whatever. The controller, what it does, it will receive a signal from Kubernetes API that something changed. It will scan the definition and reconcile the function definition with the deployment, replicas, whatever we have inside the Kubernetes. So every time you apply a change, it will do a rolling update with that change. Also, we can delete the function, and the controller will react to it.
So this looks really good, Stefan. I think one of the things I just want to make clear is that this doesn't mean that you can only create your functions through kubectl, right? What it means is that we've actually, rather than we used to create deployments and services, now we would create function instead. Yeah, if that makes sense. So all the same parameters will actually be there. It's just the actual bit that creates the end of the line thing that we need would be in this controller instead. And to begin with, because we have folks on 1.6 and 1.7, we probably actually need to think about a strategy where we can maintain compatibility with older users and people that are running it in production already. So that's something we discussed. We're gonna put on GitHub and open up to people so they can start to kind of help us decide the best way of doing that.
Yes. Another thing that I've been using to create this controller. So inside the Kubernetes project, there is a new project that has been started at the beginning in August, and is named Code Generator. So what I've been doing is what you have to do is just create a struct with your custom resource, and using the code generator will basically create everything that's needed to work with the Kubernetes API. The best part about this is that we can apply the same version and the same backward compatibility that Kubernetes is applying to its own API items to our API item. So right now, inside the project, I've created version 1, alpha 1 of our function definition. So when we add something new, we can do alpha 2, beta 1, and so forth. And we can actually ensure backwards compatibility like Kubernetes is doing like 3-4 versions before. So I'm pretty excited about this because we can actually have backwards compatibility that today we don't have.
Yeah. And this is only within Kubernetes. So this doesn't touch Docker Swarm or Nomad. And so I think the depth to which we go with this stuff should be the depth at which we can still be agnostic. And we'll look at doing auto-scaling through Kubernetes natively, as well as having that option of doing it agnostically at that higher level. But at some point we may find that we are putting features into some backends and not others, depending on customer or user requests. So are there any questions for this? 'Cause it's quite a technical concept, it's quite a sort of different approach of doing things.
Does this mean that it breaks the provider model, or is the gateway still going to talk to a provider, which is then going to translate the the job request into a request for the Kubernetes controller?
Yeah, that's Nick speaking, isn't it?
Yeah.
Yeah, no, it will work. So my theory is it will work exactly the same. This will become yet another service running in Kubernetes, another container. And instead of us creating a deployment and service via the Kubernetes API, we'll create a function. And so it will be super fast. And then everything else would look the same. When you queried system functions, again, it would query the function CRD instead of the deployments with a label.
Sounds cool. No, I think that's a good, sounds like a good plan from a backward compatibility perspective. Then I guess you just run a different version of the provider, which is probably pretty cool as well.
Yeah. So Lucas, I know you're quite heavily in the code at the moment. Eric, the same. This doesn't mean what you're doing in any way would be redundant or unnecessary. In fact, it's even more applicable, right? So your pull requests and the code that you're doing will probably just be merged into where they are, and then we would end up having that behavior living in that new controller. We might actually live in both places at once until we get everyone over to 1.8. And so it's just as important, and it makes just as much sense. And this shouldn't increase the difficulty level for you. And if you've got any questions, we'll support you and just make sure that you're happy with it. Okay.
All right. I think this all looks really cool. Just no worries on my end in terms of working the wrong spot or anything. I think it makes a lot of sense for Kubernetes.
Thank you.
One thing I think it's really important if we go forward with this new controller is that we can actually give our Kubernetes users more power over what they will do with the functions. So maybe a Kubernetes user will not use our CLI to deploy a function. He can use kubectl to deploy that function. What that means, if they already have a CI/CD pipeline that they are using for Kubernetes right now, they can keep using it even if they switch some parts of their backend, for example, to OpenFast.
Yeah, so I mean that's theoretical, but I think my direction at the moment is going to be that the best experience with the CLI, anything that's deployed via this mechanism will be best effort. Because the CLI does other things like templating and building out images. Just to be clear.
Yeah. The CLI you could use the CLI for, I don't know, continuous integration to build your image, to push your image to the registry.
Yeah.
But usually in the Kubernetes world, you'll have some kind of continuous deployment tool that's automated.
Yeah.
And usually that kind of tool uses kubectl and that's it, or uses, I don't know, something like Helm.
Okay.
And we can make sure that those stuff will not break.
Yeah.
With OpenFaz.
Yeah. Okay. The other thing that I want to do is try to not embarrass Amir. I've found your code, and I'm just going to hit Faz CLI store list.
Great. Thanks.
And wow, there you go. Seems to be working. So we've got things like the inception function here, left pad, Docker Hub stats, looking pretty good. If I do just store, I can see that I can deploy them and inspect them. I don't know if any of the other parts are working yet.
Yeah, Incep working. Just deploy is not actually deploy. I just had some tries on deploy, but it didn't work.
Okay.
Yeah,
we can help you. I mean, I mentioned to Burton, Eric, and Nick that you'd be working in this area, and I think we've all worked in that area, so we're happy to support you and help you out. Just reach out.
Yeah, sure. Thanks.
Okay. So I know we're kind of running close to time now. The last thing that that I had in my deck was this really, was what was next. And this is what I showed at KubeCon. So the function store launched so quickly I couldn't even update the slide. I think the feedback we've had so far is really good. The people even that were working with the project didn't even realize it had been done. Derek is a public app now, and he's administrating on Moby, which is Docker's core repository. Really excited about that, as well as helping us out. Documentation site looks to be in good condition, the way John left it. The only thing is we do need to go through and make sure it's up to date. So if anyone's interested in helping with that, definitely could use your help. Because I think, again, once we launch this, it's just going to be another big step forward. On a technical side, Robbie helped us out with an event grid connector, but we really could do with an Amazon SNS or SQS connector. It might be something that even Nick, that you may have an interest in. I think once we have that in place, again, it's just going to help OpenFaz be the right option for people. Open tracing is interesting. Multi-tenancy is kind of interesting too. But another thing along the lines of what Stefan is saying is, like scaling deployments back to 0 and then being able to get them back up to 1 when somebody calls them later on as an option could be a really great thing for us to be doing technically. Okay. So that was everything that I had. I know we covered a whole bunch of stuff here. I just wanted to give a bit of time for Q&A. Anything that we've shown or that I've mentioned, or just generally coming up. Over to you.
So for the Kubernetes, the thing that Stefan just demoed, is a function a new Kubernetes construct, or?
Yes.
Okay.
It's like a deployment, like a service, like. It's the same as a deployment, for example, but it also creates a service behind. So it's more than a deployment at this point.
Okay. So what was it where deployments are lacking, where they decided that they need a new thing that's a function? Like, what was the need for that?
The need for what? For us to have our own custom type? Why we?
No, for why Kubernetes decided to make this new construct.
No, basically what they've done is, because they have this idea of open close principle, they don't want to change their code base. They'd rather people extend Kubernetes by adding their own objects. And so it's actually they didn't decide that at all. They're like, deployments are actually fine now, use them in production. We're the ones that have come along and gone, well, actually, it would be really great if we had our own abstraction.
So the function type is something that I created, is not inside Kubernetes.
Yeah. Does that make sense?
Yep.
I've just seen that Ganesh and Vivek are on the call. Welcome to the contributors call. I guess you guys maybe joined a bit later on. This is recorded, so I can send you the link later. Do you guys want to introduce yourselves?
Hello.
Hi. Could you speak up a little bit?
Yeah, this is Vivek. I am from India.
Sorry, we can't hear you, Ganesh. Do you want to try again? How about we?
Hello.
Hello.
Yeah, can you hear me?
That's perfect. Yeah, who is that? Vivek? Vivek?
Yeah, this is Vivek. So,
Hi.
So I'm from India. I currently work for Akamai Technology here in Bangalore. I'm interested in contributing to Open FAS, and that's why I joined the call. I've already contributed to FAS CLI, but I was looking something to pick up so that I can contribute.
Okay. Do you have anything, or do you need some help?
Yeah, I started with AWS SNS connector. I mean, I started researching on how to connect with AWS SNS. So
Perfect. Well, that's one of the big things that will help us out. So yeah, I think actually I remember talking online with you now. So the idea behind that is that if you use something like AWS, you have your Dynamo database, you have your S3 buckets, and all these kind of places where events can be generated that are kind of locked into the platform. So by creating a connector, what we're doing is finding a way of running functions when those things happen instead in OpenFAS.
Okay. So OpenFAS functions will work as a subscriber in that case, and SNS will publish the messages to OpenFAS functions.
Yes, exactly. And then the idea of the connector is that sits in the middle. That's what's exposed, receives the call, and then decides which function to invoke.
Okay.
Would the connector itself be a function, or would it be something else?
I think it would depend on the interface with AWS. If you're looking at SQS, that's a queue and that needs polling. So that could be a timed function. If you're looking at SNS, that is a pub sub. And so really, it may be able to be a function. It just depends on how long the handshake takes.
So I was working on that. So in order to be a subscriber, like if you want to make HTTP endpoint as a subscriber to SNS, you have to send a post request that will say that HTTP endpoint is want to subscribe. Then SNS sends a confirmation URL where that confirmation URL, you have HTTP endpoint has to confirm on that URL. Then subscribe will be successful, and then SNS will start publishing the message to subscriber.
Great. Would you be able to draw a picture for us, maybe using an online drawing tool, or PowerPoint or Word, and upload that to the GitHub issue?
Yeah, sure, I can do that.
Thank you very much. I think that would really help explain the flow. The other thing is we can also help you find some other areas where you can quickly get some commits into the main project. And I'd like to put if you like the idea, I'd like to put you on this slide. So next time I talk about the project, people can see that you're a part of it too.
Yes, sure. I mean, I'm really interested in contributing to a main project. I'm an open fast.
Yeah.
So
the CLI counts to the main project too. So wherever, yeah, I'd just really be excited to have you on here. And thanks.
Thank you.
You're really welcome here.
Thanks. Sir.
We have Ganesh. Ganesh, are you?
Hi.
Hey.
Yeah, hi, this is Ganesh.
Hi.
Yeah, I'm also from Bangalore. So I work in a startup now. And so recently I have been tweaking around Docker and Kubernetes a lot. And that is when I found OpenFaaS and I started experimenting with it and I liked it. So I guess started with that Afterburn for Java.
Yes.
Yeah, so I guess Amir, the other guy, he created for Scala, right?
Yes. That's
Yeah,
right.
so I had a different opinion on it and tried to create it, and I ended up with that bug in copy functionalities.
Okay.
Yeah, I also
yes.
have.
Yeah.
Yeah. I also have a couple of things in mind. So one of the things which I was thinking is, so when writing functions in Java, so most of the time Java has these annotations given out to people. So how about something like just annotated with this is my function, like OpenFaaS function as an annotation, and just in the main function just say that handle with OpenFaaS afterburn, and it will configure your handlers and everything instead of writing the handler again and again or keeping it in and out. So this is mostly like how Java handles it. If you see Spring framework or any framework, there is a lot of annotations everywhere.
Mm.
So I was thinking on that. That was one of the other ideas I was thinking about.
Okay, I like that.
Yeah.
Would you be able to raise a proposal somewhere and just tell us a bit more about how that works and how it looks in Spring?
Yeah, sure. I will do that.
Brilliant. And
also,
again, I'd really like to have you on this slide too. I'm going to have to shrink everyone down and squeeze some more people on.
Yeah, sure. Also, so I was seeing in that Slack channel that day that we were looking for some cool functions in store, like something simple.
Absolutely.
So
please.
I was hacking around this Identicon in Go. So similar to that QR code generator.
Yeah.
So this is just, it creates Identicon for a given username, like how it looks in GitHub.
Oh, cool. Yeah, that would be really awesome.
Yeah, so we can assign it to the new functions which come in for the store or something. We can use it internally.
It's an avatar generator?
So there was a function. I will link the repo in sometime in the Slack channel.
Yeah, put it into the contributor Slack or the OpenFaaS Slack. That sounds really interesting.
Sure. Yeah, cool.
Are there any other areas you'd like to work on in the project? Is there anything that you've seen on Trello? Do you want an invitation to Trello? Yeah,
I would like an invitation to Trello. I will have a look around it and I will update you guys.
Brilliant. I'm really excited to have 2 new contributors on the project. Look, just contact us on Slack or me directly. We're just here to help. I really appreciate you spending your time on it.
Yeah, nice meeting you guys as well.
Yeah. Is there anyone else that I missed? I know we've just gone over time now. Ed, good to see you there.
Thanks, Alex. Good to listen in on things. Nothing to report except that I'm looking forward to much more success in the new year.
Yeah, likewise. Well, unless anyone has anything else to add, I think we'll close the meeting there. Thank you all for joining. I appreciate you coming out on your Sundays, mornings or afternoons, whenever it is, and helping OpenFaaS happen. It's been a very, very big year for the project.
Thanks. Bye-bye.
Thank you. Bye-bye.
Thanks a lot, guys.
Bye guys.
Cheers, Richard. Peeking up there.